In 2019, Ant Financial served over 1 billion customers using a fraction of the workforce required by traditional banks. Their model isn't built on human processes, it's built on an AI-driven core. This potential has triggered a massive wave of investment, with 90% of executives launching AI initiatives. Yet fewer than 40% of those companies report seeing any actual business gains. Most of this failure stems from a single misconception: the belief that AI is a localized software upgrade that can be plugged into an existing siloed workflow. Satya Nadella, the CEO of Microsoft, describes AI as a new runtime for the firm. In this view, AI is the underlying architecture that determines how every piece of data is processed and every decision is made. Unless an organization dismantles its specific human and systemic failure points first, deploying highly accurate AI risks accelerating the processes that compromise business value. Traditional 20th century firms are defined by human constraints. Their ability to grow depends on the scale, scope, and learning capacity of their people. In these models, adding more workers eventually hits a ceiling. Coordination costs and physical limits lead to diminishing returns on every new hire. Digital native firms avoid this plateau. By integrating AI into their operational core, they can scale production and variety without the same overhead, allowing value to climb well past traditional limits. We are seeing a collision where digital models violently overtake traditional ones. As network effects amplify the volume of data, the gap between these two curves widens into a permanent competitive advantage. Forcing an exponential technology into a constrained human architecture doesn't just fail, it breaks the logic of the business. To avoid this, we have to deconstruct why these systems fail at the atomic level. The first major failure point is algorithmic misalignment, directing a powerful engine to solve the wrong problem. Take the case of a telecom provider that used AI to predict which exact customers were most likely to cancel their contracts. Marketers use these accurate predictions to target at-risk customers with expensive promotions, but the churn rate didn't budge. They had exhausted their budget on customers who were going to leave regardless of the incentive. The correct question wasn't who is leaving, it was who is persuadable. By shifting the AI's objective to identify who would actually respond to an offer, the company could have eliminated the waste of targeting the unmovable. This illustrates the danger of ignoring asymmetric costs in predictions. For a retailer, the penalty for underestimating demand on a high-margin product is far more destructive than making the same error on a low-margin item. Isolated data science teams often optimize for overall accuracy. They treat every error as equal, unaware of how these asymmetries impact the balance sheet. A mathematically perfect model will flawlessly destroy value if it's engineered to hit a proxy metric instead of a business objective. Beyond financial waste, there is a psychological cost. AI-driven efficiency can feel like hostility to the customer. Dynamic pricing is the most common use of AI to match supply and demand in real time. During the 2017 London Bridge terror attack, thousands of people tried to flee the area at once. Uber's algorithm responded to the spike in demand exactly as it was programmed to, surging prices by over 200% for those trying to escape. The algorithm was economically efficient, but the result was a brand disaster. Mechanical optimization can instantly turn a relationship of aligned interests into one of opposing interests. Stripping all friction from a system can maximize short-term revenue, but without human guardrails, it can permanently destroy customer trust. This friction also exists internally. When AI is deployed purely for productivity, it often degrades the long-term capability of the workforce. For decades, surgery was taught through a model of shared struggle: see one, do one, teach one. Trainees won under direct physical supervision. Robotic surgery has changed that physical proximity. Today, the expert often operates from a remote console. They can do the entire procedure themselves with the robot, leaving the trainee to simply watch a screen. By removing the trainee's ability to make and recover from minor mistakes, the system pushes them away from the learning edge required to master the craft. This creates shadow learning, deviant, rule-breaking methods workers use to get the experience the system now denies them. Sidelined residents often bypass the expert at the console entirely, secretly turning to super scrub technicians for the technical insights and feedback they need to actually learn. We see the same pattern in finance. Junior analysts run shadow valuations to understand the whole process, refusing to be reduced to mere data scrapers for a valuation algorithm. Maximizing immediate productivity through AI can starve an organization of future expertise. True architecture must intentionally design feedback loops and struggle back into the work. The final barrier to success is the attempt to scale AI through isolated, localized use cases. Traditional departments often deploy AI independently. They solve small, local problems without ever connecting to a unified core. These fragmented systems eventually clash because they are built on contradictory metrics and walled-off data pipelines. Reaching true scale requires reimagining a core business domain end-to-end, rather than just fixing a single isolated step in the process. An airline cargo domain encompasses 6 tightly intertwined activities, ranging from rate negotiation and space allocation to booking and billing. One airline replaced siloed guesswork with an integrated AI dashboard. The system learns from the decisions made across all 6 activities, allowing agents to book space with far more confidence. Success required cross-functional agile squads, teams that combined business leaders, data scientists, and frontline agents into a single unit. Scale is not achieved piece by piece. It happens by reusing data and technology across a unified domain to trigger a cycle of continuous improvement. These requirements form the AI factory, a unified horizontal core consisting of a data pipeline, algorithms, and an experimentation platform. The first layer of success is alignment, setting atomic-level business metrics that account for the true cost of errors. The second layer is the human loop, designing systems that protect the ability of experts to teach and novices to struggle. The third is structural, breaking down vertical silos to allow data and insights to flow across the entire organization. AI can eliminate the traditional limits of scale and scope, but only if the enterprise is willing to rebuild its operating model from the ground up. True competitive advantage rests on the total structural integration of precise business logic, continuous human learning, and